Hi friends, today we'll be covering about big data Hadoop stack. So last module we saw what are the three V's and what is a big data. Now we'll go in depth. We look into the Hadoop stack and tools and technology associated with big data. And the topics would be the Hadoop beginnings and the framework and HDFS and what is the Hadoop Zoo and the major ecosystem or major components of uh, Hadoop. So in lecture 1, we'll see the beginning, how the Hadoop came into. So Apache Hadoop is an open source software framework for storage and large scale processing of data set in on cluster of commodity software. So if you look at the definition closely, right, uh, Apache is a company and Hadoop is a product, right? It's an open source. What is an open source software? A software is open when you can download it, right? That is for free. That is one thing. And another thing is that you will have the source code also with it. So you can modify the code also. Like if you go with the Microsoft or any proprietary based software, they won't give you the source code so that you can change it, right? You won't be able to modify the code. So here it is an open source software framework for storage and large scale processing of data sets. So here we talked about the volume V, right? Here the volume is huge data set on cluster of commodity hardware. So we had seen the definition of commodity hardware previously, right? So commodity hardware are not high-end servers. It is easily available hardware. So cost-wise or economic-wise, it would be a more cheaper to going for a commodity hardware. So Hadoop was created by Dow Cutting, and I think we had seen this in the previous slide also, and Mike in 2005. And so the major thing is that we are moving the computation to the data, right? Generally, what happens in any processing, any CPU or any mainframe is what happens is that you will have hard disk and you will have a processor, right? And you have an application which is running and a database which will store the data. This is a basic component in any hardware computer, right? Any server. So what will happen is when you run an application, right? When you run an application to fetch a data, what will happen is the data will be stored in the hard disk. The data will be fetched by an application, and it will be taken to the CPU where the processing will happen, where the threads, what you call the Unix process, the threads will run and it will process it. So that is a general concept. But in big data or in Hadoop, the major difference is that the computation will move to the data. So what will happen is that the data would be sitting in a different commodity hardware, and it will have a CPU, it will have a RAM, and also it will have a hard disk. Basically, that is where the data will be stored. And what will happen is the Java process will run at the individual commodity software. So processing will happen at the data level. So that's what here means. It means moving the computation to the data. I hope it is clear. Then scalability. So that is the reason we had talked that scalable. It is scalable. So what happens is that even in case of a huge increase in volume, suddenly based on time, right? Next year or in future, if the space or the hard disk capacity increases, it has nothing to worry. We have nothing to worry as we can just add one more commodity hardware into it. Since it is a distributed processing, the CPU, there's nothing called a bottleneck at the center, right? What happens is that if you have more data going into the CPU, which is a centralized, the scalability is a question because now with existing data, it might work well. But in future, when the data increases, what will happen? The same CPU will be there, but the data would increase. So what will happen to the processing? It will slow down, right? So what generally they do in the industry, they'll upgrade it. They'll upgrade the processor. That's what is happening in the industry for last couple of decades. So here, since we are moving the processing to the data, scalability is one of the selling points because you can just add one more commodity hardware and the scalability would be taken care. So next is reliability. What is reliability? Because now we have the software going to the distributed data. What happens is that we have data lying all over the place. in the sense that it would be in the cloud, it would be there. But what happens is that we'll have a huge commodity software. So there is a question of reliability. If you go for a high-end server, hard disk, the reliability won't be questioned, because now we are purchasing a hardware which is not of the high standard, because there's a price associated with the quality, right? So what we do is that we will have a backup of it at three places. So basically the data would be stored in three places. That is redundancy. So that is how we maintain the reliability. Even if there is one hard disk failure, there will be always a backup in another two places. So another thing is that when you have one single CPU, right, or one hard disk, what is the chance? Like you have a one person, right? Like it is, they will tell why three, why not four? Why don't we have a backup for four or two? Generally, they do a backup for two, right? In case of a high-end server, they'll have one copy and they'll make a backup. Why three? Generally, if you look at, there's only one person, and let us say it's birthday, will fall once a year, so it will be only one. But suppose there are 365 people in a room, at least statistically speaking, there will be one birthday coming every day, right? So when you have more number of commodity hardware, right? Let us say 365. So the probability is that one will fail every day. If the failure rate is once a year for a particular hardware. So that is the reason, like, so we'll have more failures in case of Hadoop, since we are going for a commodity hardware, but it would be handled by taking a backup of it three times. So it is getting stored in three places. So it is reliable. So that's how they do. So, and also the concept of this has come from the Google Big Data. Sorry, Big Data. So basically here that is a Google file system, and you see that it would be stored in three different places. So that's the example which I had given. Like, if the computer is failing once a year, let us take, and since we are going for commodity hardware, and there are like 365 computers, and at least one will fail a day, right? So you multiply it by another into 60. So what will happen is it will be into 30 for a month, and into 60 or 12 per hours. Then it will fail hourly once the number increases. So the new approach to data is keep all the data. New kind of analysis schema is read. Okay. So what is happening in any relation database is that you will create a table. So the structure would be there. So you will create a table with a column. You will have generally like employee information. So if you want to store an employee information, you will create a table called employee, let us say. What will be stored in the employee? His name, his gender, his address, his payroll, everything would be stored. So there would be a schema for a table, right? So then once the schema is created, what will happen? The data would be stored, right? Then application will, that we have a GUI where a screen will pop up, and you will enter his name, age, address, and that would get stored in the backend. But in case of Hadoop, what they do is that the data would be there and the schema would be there. Only during the processing, the data would get loaded into schema. So what is the advantage? So schema can be modified anytime. So it is not like struck to the schema. So once you have the data in the schema, when you want to modify the schema, there would be a lot of problem, because you have data in it. Now the data would be separate, and the table schema would be different. So the modification, like addition of columns, would be more easy. So we have small data complex algorithm versus large data and simple algorithm. So that is the thing. So once we go to the lecture 2, we'll go to the lecture 2 where we'll see the different framework in detail. So what are the basic framework? We had already seen about HDFS and MapReduce in the previous slides. So what is YARN, we'll see in detail. And Hadoop Common is those, when you install Apache Hadoop, right, you will have a set of components which come along with it. That is for processing of the Hadoop system itself. So those are the folders which will be automatically created. Next is HDFS. we saw what is HDFS, that is distributed file system, which is nothing but where the data is getting stored. And next is yarn. Yarn is yet another resource negotiator, and we'll see it is previously we didn't have yarn, we had only MapReduce. So MapReduce used to do both the resource handling part and also the processing part. So basically it was doing multiple jobs. One was it will map and reduce it. Basically it will start processes, and also it will handle about the resources, like how to allocate resource. So that part of resource handling was taken out in the next version. So we will be also seeing it in detail in the next module. So that is yarn, like yet another resource negotiator. And next is MapReduce. MapReduce is the one which we had seen, and we'll be giving examples for MapReduce. This is nothing but a Java program that will run uh, at the commodity hardware at the data level. We had seen that, right? So the most important thing in these two is HDFS and MapReduce. These are the modules which we'll be covering in depth, because HDFS is nothing but the hard disk or the data, and how to access or process the data is done by MapReduce. So those are the two components we'll be talking in module 2 and module 3. So we have seen that if you see the slide, right, HDFS is storage, and yarn is as I was talking about, it will handle the resource allocation, and it will negotiate for resource. So whenever a processing happening, there will be a queue of applications lining up, right, for the resources. What is resource? Resource is nothing but a CPU or a RAM. For example, a job is running, another job is needed to be run, means it will wait, right, because currently the CPU is busy. So there is no resource for the application to run. So that handling of that resources, which is basically CPU or memory or a hard disk space, would be done by yarn. And next is MapReduce. What is MapReduce? MapReduce is nothing but a Java, or it is a processing language. So MapReduce, yarn, and HDFS, those are the three components. So HDFS and MapReduce, as I told earlier, that these are the two most important components in big data. One is HDFS. So what is HDFS? HDFS is a layer where you store the data, and MapReduce is a layer where you process the data. So if you look at that, right, we have master node and a slave node. In HDFS layer we have something called name node. Name node is something like metadata, where you store all the details of what are the files which have been stored in different hard disk, right, in different commodity. So it is like a metadata. It is like address book or a directory where you have not the data but the pointer to the data. And see, we have the name node and data node. So what is a job tracker? Job tracker is a processor. Here you are talking about an application. So it is a job tracker that will start individual tasks tracker, and it will monitor it. So basically it is just like a manager who is looking after 5 or 6 people under him. Those are the task tracker, and those would be the threads which would be running in the commodity hardware, completing the application. So once an application runs, based on the type of application, 3 or 4 task tracker may be started, and job tracker would be monitoring all those tasks. So that is MapReduce layer. So MapReduce consists of a job tracker and a task tracker. Job tracker is a main which will monitor the task trackers. So previously we had seen about MapReduce. Now we will see about HDFS. What is HDFS? It is Hadoop distributed file system. So it is a distributed, it is scalable. We saw the definition of scalable, and distributed in the sense it will be at different places. Geographically speaking, it will be there in the cloud, and you can distribute it. It's a portable file system, and it is written in Java. All the framework, right? Hadoop framework has been written in Java. Not only HDFS, but also MapReduce has been written in Java. So this is the architecture. We have one more module, the second module. We are in the first module, which has 3 components, and we have module 2, which is about HDFS, where we'll be seeing about the architecture and the performance, and we have module 3, which is MapReduce. So we'll be talking about HDFS in detail in module 2. So at a high level, if you see HDFS, right, we'll have read, basically the name node is a metadata, as I had told earlier. It will have the definition of all the data stored, and the data would be stored in the data nodes. You see the rack 2, right, rack 1. The data node is a physical place where the data would be stored, and client will either read or write. So basically what the client will do is it will go to the, we have rack 1, rack 2, rack 3. So that is where the data node is getting stored. So what happens when the client starts it, it will first go to the name node, right? Because the name node is the index where it will have all the data about the details. So for example, we have a record created in the employee table. So the employee table data would be stored where? It would be stored in the data nodes. So when you want to access a particular employee's names data or information or a record, once we run an application, select star from employee table where employee name Gopal. So what will happen? It will go to the name node and it will see where the file is running, where my data is stored, right? It is in metadata. So it will indicate it is stored in rack 2 block 3. So it will go to the Java process, or the MapReduce process will go to the rack 2 and it will fetch the block, and that is retrieval, right? So we have a HDFS client. So HDFS client will first interact with the name node. Then you have something called secondary name node. That is for journaling purpose. We'll see it in more detail. So basically, what does the name does it? We saw about replication, right? If you see the color of the data node, right? If you see the black color data node, it will be in 3 places, right? I don't know whether I can show you. This is 1, this is 2, this is 3. So these are the 3 places. Previously, under the topic of reliability, we had talked about the backup, right? It will be stored in 3 places. So that is called replication. And how will we know whether this data node is working? That is called heartbeat. So what heartbeat will do? Every 3 seconds, it will send a communicate with the name node to tell that it is alive. So if the name node does not receive a heartbeat after 3 seconds, it will assume that the data node cannot be reached or it is dead, and it will replicate once more. So what is MapReduce engine? So this is HDFS, right? And this is MapReduce. MapReduce is the processing, where the processing happens, and HDFS is where the data is stored. So here it is an engine which processes it, right? It is a Java-based application which runs. So job tracker, as we had seen earlier, is a slave process which runs, right? It will start the different task tracker. So job tracker will start a task tracker in different places, disk 1, disk 2, disk 3, and it will monitor it. So job tracker, as the name suggests, it will monitor the task. So job comes first, task is a component of job. So job tracker will monitor the task tracker. So now we go to what is yarn. Yarn enhances the power of a Hadoop cluster. So what happened previously? We had in version 1 we had only MapReduce. So what happened? It was going well until the cluster it became a huge success, and the data kept on increasing. And once it reached certain level, there was a saturation, because what happened, as I told earlier, the MapReduce was doing not only the processing of managing the task tracker and the job tracker, but it was also handling the resource part. So that created a kind of bottleneck, and to improve the cluster utilization, because there are thousands of clusters being coming. So to maintain the scalability, that specific part of resource handling was separated, and it was done by yarn. So it's MapReduce compatibility. So another advantage of this is that it improves the cluster utilization. And the thing is that once with the yarn, right, all the existing application won't get impacted. See what happens that when you change it, right, you take a function, what will happen to the existing application which is running, right? Will it get impacted? No, it won't get impacted. So even with the yarn in place, the MapReduce is still compatible with the old programs. So that is where the compatibility is taken. So the existing application which was running in the MapReduce version 1, it need not get impacted because of the introduction of the yarn. And it's not only that, it supports other workload. Previously it was only supporting MapReduce, but now we'll see in the coming slides how it supports other workload. So next is the Hadoop Zoo. What is a Hadoop Zoo? So these are the different components. See, we had seen, if you look at the slide, right, we have seen HDFS and we have seen yarn, which is MapReduce version V2, where I talked, right? Previously in V1, we had only MapReduce. In V2, we have yarn also. So this is the entire Apache ecosystem. And we'll be in our course, right, we'll be covering the most important part, which is HDFS and MapReduce. And there are different components like pig. We'll be talking in detail about hive. I'll give an overview of all this in the next slides. How to figure out. So basically, if you go to the original the diagram created by the Google, it came out, right? The big data concept came out when Yahoo was searching or designing a search engine. So they could not handle the amount of volume of data, and also they could not handle the structure of the data because it was not in a structured format. So if you had gone to the previous module, you would have, I would have given explanation where what they did was, it was a white paper from Google, and the Yahoo team which developed the Hadoop replicated what was there, and they did their own modification. So this is what the original Google stack looks like. If you see this and the existing stack, there will be a lot of similarities, right? You have something called Chubby. These are the things which we don't have now. So you have something called Big Table, and we'll see how it has been replaced by the existing system. So, and you have MySQL MySQL gateway, and you have Google file system, which is nothing but HDFS. You have Big Table. We see what is the different component which current thing have. We have for data integration, we have MySQL. What is the data integration tool which we have in our existing component? We'll see like Dremel and Chubby. Okay, so these are the existing Facebook version. So in Facebook, we have something called Hive. We have something called Zookeeper. We'll have something called HBase, Hive, and these are the name you would be aware of. So HBase is where you stored, it's a columnar database where unstructured data is stored. Hive is nothing but a warehouse where a structured kind of table is stored, like a table. And you have something called Scribe, which is nothing but data integration tool where you move the data into the existing system, right? So you may have data in the current system, and when you want to migrate to Hadoop, you will be using Scribe. And Zookeeper is nothing but a coordination. When you have a lot of clusters, we'll see all these things. So same like in Yahoo, right? This is the Facebook version, and this is the Yahoo version. You have the name would be different. Like you have Data Highway. Here you will have Scribe, right? Both the functionality would be the same, but the name would be different, right? So don't worry about the name. See here in Facebook we had Hive. In Yahoo we had a pig. There's a history, like in if you look at Yahoo, right, it is more like a search engine, right? So there you need kind of a scripting language, an algorithm, whereas Facebook is, you don't need much an algorithm, right? You upload file, you store it, and you retrieve it, more like a warehouse kind, right? More like a table. But in Yahoo you need some language also, like with controls, if then. Like what happens when you go for a search engine? In a search engine, you type like top 10 big data training institutes in Chennai. What will happen? That's a kind of algorithm written, right? So that's why you have pig. Pig is nothing but it's a high-level language. It is used for ETL, where you can script it. It's a pig Latin is the language. We'll see in depth of that. Okay. Data integration is Data Highway. And you have something called Scoop. We'll see how that is handled, how data is getting loaded and extracted from the Hadoop concept, Hadoop component. So these are all language compilers. So what does a compiler does? What it will do is that it will compile the language into MapReduce. So I was talking about, right, the most two important concepts are HDFS and MapReduce, right? So MapReduce was a language which is difficult to learn when Yahoo or Facebook started it. Then they realized that existing people had a skill in Oracle and they had a skill in Unix. So Hive was developed by Facebook for the user who had previous knowledge in Oracle. So that is why you have something called warehouse, you have table, you have select statements there. And pig is for those people who have done a bit of scripting like in Unix, right? So you can, there are like loops, conditions there. LinkedIn version. So LinkedIn is other. So here also you have something called Scoop, right? Scoop is what currently we are using. Kafka, that is for streaming, and you have same Pig and Highway, and also Zookeeper. So Cloudera, right? This is a VMware which I talked about in my introduction. So this is where I will be giving a VMware, uh, which is a Cloudera version. Cloudera, you have many, even though Hadoop, Apache Hadoop is an open source framework, a lot of individual companies have taken that basic framework and they create a wrapper around it so that it will be easy to use. So most popular, to my knowledge, is Cloudera, and you also have something called Hortonworks. These two are the leading vendors in big data. So if you see, like, you have Fume and Scoop. So in the project, or once you complete this course, right, in the internship we have a project which will involve Fume and which will involve Scoop for getting data. So Scoop is the most important component, data integration, because data has to come in, and you will have a Hive, which is a table, which is also will be used in that project, and you will have a retrieval of it. Retrieving, you need to store the data and you need to retrieve the data, right? So we'll be talking about the Uzi, which is a workflow. And proceeding next to the lecture 5, we'll see the different components which we had talked about in detail, right? We had talked about Pig, Hive, and we'll be talking about all those components in detail.